A very warm welcome to my dear students. I, Dr. Shilpi Gulshrestha, CDOE, Associate Professor from Jaipur National University. Today I will take a quiz on queues. Queue is a very interesting topic on DSA, that is data structure. And now we will start a queue, some questions for our understanding of a queue. In my previous lectures, I took queues, algorithms, questions and as well as the code of queue. Now today we are going to solve some question in the form of MCQs. So here is my first question, and the first question is, what is the order of elements in a queue, right? So here we have 4 options. So I hope you know what is the queue. So queue is just look like in this manner. So one end we have rear and the another end we have front. So on which phenomena queue is working? So the first option is FIFO. FIFO means first in, first out. The second option is LIFO. LIFO means last in, first out. And the third option is random, and another option is none. That means queue is not working on all these options. So what will be the answer? It's a very basic question on a queue. So please understand the question and give me the correct answer. So here we have our answer. The answer is FIFO. What is FIFO here? FIFO is first in, first out method, because we have a queue like this, and we have 2 ends. One end is known as rear and the another end is known as front. So from the front side we will delete element, right? Maybe we have these elements. So if I want to delete an element, I want to delete from the front side, and if I want to insert one more element, so I will use the rear end. That means this processor is known as who is coming first is processed first. That is why the phenomena of queue, the element in a queue inserted with the help of FIFO. That means first in, first out. So the answer of this question is option A, right? Okay, then we move ahead to the second question. So here we have the second question. Question is, which operation add an element to the queue, right? So if I have a queue like this and I want to add an element. So as we know by the first question, queue is work on FIFO, first in, first out order, right? So if I want to add an element, so from where I can add? So I can add from the rear end, right? So what is the name of that particular operation regarding queue? We have 4 options. Number 1, option A is insert, option B is push, the third option is known as NQ, and the last option is known as add. We are going to select an option in the respect of queue here, right? So again, this is a very easy question. So try to evaluate this question and give me the answer. Okay, now we will see what is the answer of this question. So the answer is NQ, right? So the answer is option C. Option C, that is NQ. When we are talking about queue and I want to insert an element, right? So if I want to insert an element in my queue. Let us assume that I have a queue. We have two ends, one is front and another one is rear, right? So maybe this is my front, and in this situation my rear is pointing here, and I have some elements. Maybe I have some elements like 1, 2, 8, and now I want to add one more element to it, that is element 10. So my rear is updated by 1, now it's pointing here, and this operation in the respect of q is known as AND queue. So according to the question, the explanation is the AND queue operation adds a new element at the rear end of the queue, right? I hope this question as well as the answer and the explanation is understood by you. So we will go ahead to the next question, question number 3. So here we have a question number 3. So the question says, which operation removes an element from the front of the queue? In second question, we discuss about the insertion of the element, and now here we are talking about a deletion of the element in respect of queue. So again, if I have a queue, let's say with 4 elements like 2, 8, 6 and 5. So in this way my front is pointing here. So whenever we are talking about queue and we want to delete an element, so this operation is known as option A, dequeue, option B, remove, option C, pop, and the last option is, let's say, option C, cut. So it's a very easy question. So try to evaluate this question and give me the answer. So let's move to the answer part. So here we have 4 options and the correct option is dequeue. And the correct option is dequeue. Right? Dequeue. Dequeue means deleting an element. Now, again a question of understanding from where we are deleting that particular element. So we are deleting that particular element from the front. So this is the front of my queue, right? Here we have some elements, and if I want to delete, so from here I can delete my element and my front is incremented by 1. And where is the rear? Rear is pointing here, the another end of another pointer of a queue, right? So option A is a correct answer. Explanation: the dequeue operation removes the frontmost element of the queue, right? So in this way we can understand from where it is deleted and the name of that particular operation. So option A is a right answer. I hope this is again clear to you. So we will move ahead to the question 4. Question 4. It's a very nice question. So we'll start it. What condition signifying a queue underflow? Now, first we have to understand what is underflow. What is underflow situation? If you know what is underflow situation, you can easily give the answer of this question. So the options are A, queue is full. The next option is queue is empty. Another option is queue has one element. That means we have only one element in my queue. And the last option is queue is half full. That means we have some element in it. If I have 5 blocks, 5 memory blocks in my queue, so when we are talking about it is partially or it is half full, that means we have 1, 8, 7, this type of element. Queue has only one element, that means only one element I have, right? Only one element. When we are talking about it is half full. The next thing is when queue is empty, that means there is no element. And the another one is queue is full, that means all the elements are full in it. It is completely full. 1, 8, 7, 11 and 12. So, which situation is known as underflow situation, right? This is the question. So, if you already saw the previous videos on queue, so this is very easy question for you. So, please let me know what will be the answer. So, let's discuss the answer. So, answer is option, the answer is option B, right? That means option B. Option B, queue is empty. Underflow, that means we do not have any element in it, right? If we don't have any element, so the situation is known as underflow. We have 5 boxes and the queue is empty. If the queue is empty, that means both of the pointers are pointing, here. If we are using arrays, for representing a queue, so the index value will start from 0, 1, 2, 3 and 4, right? So now the rear and front both are pointing to the place where known as -1, and if there is no element present in my queue and I want to delete an element, this situation is known as underflow. That means this is a final situation, which is we are setting when all the elements are deleted, then we create a situation again where the rear and the front is pointing on -1. Just look at this. If we have some elements in it, maybe 1, 2, 8, 7 and 11, and my rear is pointing here and my front is pointing here, right? And I want to delete an element. So first I deleted this, then my front is incremented here, then I deleted this. So in this way, when I am deleting each and everything, where is my rear and my front? So everything is deleted, so here I am pointing, where here I am pointing, right? Now you understood the concept. So explanation, underflow occurs when a dequeue operation is attempted on an empty queue, right? So this situation will occur. This situation will occur when we have a empty queue. So answer B is a correct options. I hope this is clear to you, right? Next question, then we will go ahead to the next question. So the next question is question number 5. What happens if you unqueue in a full linear queue and the options are number 1 is underflow. Number 1 is underflow. The next option is overflow, and then the third option is segmentation fault, and the last one is none, right? So what will be the answer? You have any suggestions? So now we will go for the answer. So the answer of question number 5 is overflow. Is overflow because we are talking about the AND queue of the full linear queue. That means my queue is already full and I want to insert an element, right? Is this queue is already full, 1, 2, 3 and 4, or now I want to insert one more element, so that is not possible. So the situation is known as overflow situation, right? So the correct answer is overflow. Overflow occurs when there is no more space left to the queue for the insertion of an element, right? So the answer is option B. The next question is question number 6. Question number 6 is, what is the initial value of the front and rear in an empty linear queue, right? So the options are, so we have 4 options. Option A is 0th position, option B is -1, option C is position 1, index value 1, and the last option is null. So try to read this question and give me the answer. So the answer of the question is, -1. -1, where we do not have any element in my queue, that because we are talking about the empty linear queue, right? So we have 1, 0, 2 and 3, these are my index value, and now because we do not have any element, so my rear and my front, my rear as well as my front is pointing to the situation or the position is known as -1, right? So the correct answer is option B. Okay, so this is the question number 6. Now we will move ahead to the next question, question number 7. So the question number 7 is in a linear queue implementation using arrays, what causes memory wastage, right? Which is the thing is based on memory wastage, and the options are number 1, no reuse of DQ space. The next is overflow. The option C is array size too large, and the last option is incorrect indexing, right? So these are 4 options we have. Now what will be the answer? Do you have any idea which is the correct options, my dear students? So we will go for the answer, and the answer is option A. So the answer is option A, where we are saying that no reuse of DQ space. What it means? It means if I have a queue of size 4, 0, 1, 2 and 3, and I am deleting elements to it, 1, 3, 8, 7, right? And I am deleting element one by one, right? Then there is no use of these empty spaces, because here the rear is pointing here and the front is also pointing here when I am deleting element 7. After then it will goes here, right? But we cannot use these spaces. That is why the answer of this question is no reuse of DQ spaces. So the correct answer is option A, right? So we will go to the next question. Question number 8. Here we are talking about a very important thing, that is complexity of a queue. So question number 8 is, what is the time complexity of an queue and DQ in a linear queue, right? So we have some options, that is option A is order of n, right? The option B is order of log n. The next option is order of 1, and last option D is order of n log n, right? So what will be the answer? So we will go to the next slide and I will show you what will be the answer. So the answer is option C. So here we have option C, that is order of 1, right? So the time complexity of an queue and DQ in a linear queue is order 1. Both operation means AND queue as well as DQ take constant time, assuming no dynamic memory resizing is involved, right? So the correct option is option C, that is order of 1. So we will move ahead to the next question, question number 9, that is how a linear queue implemented. So we have some options. Option A is via arrays, only via arrays. Option B, only linked list. Option C is array and linked list both. Array and linked list both, and the last option is none. So what will be the answer? So now with the next slide we will discuss the answer, and the answer is option C. Option C, that means we can implement linear queue. We can implement linear queue via arrays as well as linked list, right? So if you saw the previous videos, there I explained queue implementation via array as well as linked list. So the correct answer of this question is array or array and linked list both. So C is a correct option of this question. So the next question is 10th question, and question says, where is the rear pointer incremented in AND queue operation? And the options are number 1 front, number B middle, number C last element, and number D is rear end. So we have these 4 options. So we have to evaluate where the rear pointer is incremented, right? So which answer is correct? So according to this question, the correct answer is option D, that is rear end. That is rear end. New elements are added at the rear end, so rear index should be incremented by 1. That means if I have a queue and I have some elements in it, maybe 1, 2, and I want to add one more element to it, so 3 will be come here, and before rear is pointing here, after coming a new element, rear is pointing here. That means R plus 1, it is incremented by 1, right? So the correct answer of this question is rear end. I hope you understood the question and answer and explanation as well as. Now we will move ahead to the next question. That is, the question number 11 is, in DQ operation, which pointer is moved? DQ means deletion of a particular element. So according to the Q, we have two ends, one is rear and one is front, and deletion is happened from which end? And the options are A, rear, B, middle, C, front, D, start. And the correct answer is front. And the correct answer is option C. Option C, that is front. If you want to delete an element, element should be deleted from the front side, right? So option C is a correct answer. Now question number 12. Question number 12 says, which of the operation is not applicable to the linear queue, right? That means which operation is not connected with the concept of queue, and the options are number A, NQ, number B, DQ, number C, top, and number D is front. So which option is not relevant? So the option which is not relevant is option C, that is top. Top is not a relevant answer to this linear queue, because DQ and NQ are the major function of a queue, and front is a pointer. So only top is a word which is not relevant. It is relevant with stack. So C is a correct answer. Question 13. Next question is question number 13. Question number 13 is, what is the required to check before dequeuing a element? So the option A is, if queue is full. Is queue is full. Option B, if queue is at max position. Third option is if queue is empty, and the last option that none. None means not from all of the above. And the correct answer is, and the correct answer or option is option C. Option C, if queue is empty. So if queue is empty, we cannot delete a element from it. That means we do not have an element, how we can delete an element from the queue? Or we have some element and we already deleted all the elements, now we do not delete an element from the empty queue. So the correct answer of this question is option C. Next question is question number 14, that is, in linear queue, where is the first element located? So the options are option A, middle, option B, rear, option C, front, and option D is anyone, right? So the correct answer of this question is front. Is front. The first inserted element is at the front of the queue, right? So the correct answer of this question is option number C, that is front, right? So I hope this question answer and explanation is clear to you. Now we will go to the next question. Question number 15. In question number 15, which real world example best representation of the linear queue? And the options are number 1, call stack, number 2, print job queue, number C, undo features, and the last option is binary tree traversal. For all these options, we have to select the one correct answer. So the correct answer is option B. So the correct answer is option B, that is printer job queue. Jobs are handling in order. They have received, matching and FIFO behavior. That means which job has come first, it should be processed first. So queue is based on FIFO nature, and the correct answer according to that concept is become option B. Option B, that is printer job queue, right? So this is the question, and we have explanation also. So go to the next question. Question number 16. So the question number 16 is, what data structure is best suited for implementation a queue? So the options are option A, stack, option B, tree, option C, linked list, and the last option is known as heap. So I hope you already know the answer, and the answer is linked list. Option C. Option C, that is linked list, is the best method to implement a queue, right? Linked list allow a dynamic memory uses and avoid overflow situation. That is why linked list is the best for your queue implementation. So we will move ahead to the next question, and the next question is question number 17. That is, what is the primary drawback of array implementation of linear data structure queue? And the options are number 1, slow speed, number 2, that means option B is no memory, number C is memory wastage, and the last option is complex code, right? We have these 4 options, and I hope you already know the answer. So give me the answer quickly, students. And the correct answer is memory wastage. The correct answer is memory wastage, because we are using array here. We are talking about the arrays. Array based queues cannot reuse feeded space without shifting elements or a circular logic. That is why here we are wasting memory. So that this is the option, this is the correct option, option number C, that is memory wastage in the implementation of the linear queues. This is the main drawback of using arrays. Question number 18. In question number 18, it's asking, what value is typically used to indicate an empty queue? When we are talking about the empty queue, option A is 0, option A is 0, option B -1, option C says null, and D is infinity, right? So the answer is option B, that is -1. -1 means typically when we are showing that my queue is empty, my pointer is pointing to the situation or the index value, that is -1, right? -1 is a common initializing value, for front and rear to signify an empty queue. So we will go ahead to the next question. Question number 19. Which operation is used to view the front element without removing it? And the options are option A, dequeue, option B is peek operation, option C, pop operation, and the last operation is known as insert operation. And the correct answer for view, only for view, is option B. So the correct option is here option B, that is peek operation. Peek operation is generally used to retrieve information from the front of the queue, without deleting an element. So we will going ahead to the last question of this series, that is question number 20. And the question number 20 is, what condition leads to queue overflow in an array implementation? And the options are option A, rare equals to size minus 1. Option B is front equals to rare. C, front equals to minus 1, and rare equals to 0. So these are 4 options, and the correct option is option A. Option A, where rare equals to size minus 1, because we are using array, right? So if we are using array, so the index value will start from 0 to size minus 1. So according to this question, the condition or overflow is rare equals to size minus 1. So the correct answer of the question 20 is option A. I hope you understand all these questions, answers, as well as the explanations. Thank you very much for your attention. All the very best. Keep learning.